Today we're going to talk about lesson 523. We're going to learn how to deal with explicit and recursive equations and what they mean. It says you have been writing equations for arithmetic sequences so that you could find the value of any term in the sequence, such as the 100th term, directly. Today we will investigate recursive sequences. A term in a recursive sequence depends on the term or terms right before it. Let's start with this first sequence. The first thing we want to do is we want to find what the 10th term is. We can actually do this in two ways. One of the ways that we can find the 10th term is just to find the sequence generator and to just keep going until we get to the 10th term. So let's do that. How much is this increasing by? This is increasing by 6. And if we look here, this is increasing by 6 because negative 2 plus 6 equals 4. And negative 8 plus 6 equals negative 2. So it looks like our sequence generator is positive 6. So if we keep adding 6, the next term would be 16. If we add 6 again, the next term would be 22. If we add 6 again, the next term would be 28. If we add 6 again, the next term would be 34. If we add 6 again, the next term would be 40. And if we add 6 one more time, the 10th term would be 46. So we could say that the 10th term is 46. Now, if they wanted us to find the 527th term, we definitely wouldn't want to do it that way. We would want to do something else. What would be another way that we could find the 10th term? Well, maybe we could write a rule, and then we could just plug 10 into the equation and come up with our answer. So, in order to write a rule or to write an equation, we need to know two things. We need to know what our slope is, and we need to know what our starting point is. Well, our slope is 6 because that's our sequence generator. It's also our common difference. Our b, we need to find the b. So if we're adding 6 this way, we're going to subtract 6 here. So if I subtract 6 from negative 8, I'm going to get negative 14 as my 0 term. So my b is negative 14. I have enough information now to write my equation, and since this is a sequence, I'm not going to use y equals mx plus b. I'm going to use t of n and n. So I'm going to say t of n, which is my y, is equal to mx plus b, or mn plus b. So my m is 6 times n, and my b is negative 14. So if we have this equation, and I want to know what the 10th term is, all I have to do is substitute 10 in for my n. And I'd say 6 times 10 minus 14. So t of 10 is going to be 60 minus 14, which is going to be 46. T of n, which is 10, is equal to 46. And that's the same answer that I got up here. So we definitely like to do it this way better because it's going to be a lot less work if the problem asks for more information or further information away from what we have. Okay, on the next part, we came up with this equation. Let's talk about that equation. We have t of n is equal to 6n minus 14. This type of equation has a special name. This equation, I could find the value of any term. If I wanted to know what term was the term number 517, I could plug in 517 into this equation and it would tell me what that term value is. And this kind of equation is called an explicit equation. This is what we're used to using. It tells us really good information really fast. All I have to do is plug a number in for n and it'll tell me what that value is at that term number. Okay, well, there's another type of equation that we're going to talk about today, and that's a recursive equation. The next term after t of n is t of n plus 1. So say we put in a 1. We want the first term. We put a 1 here. The next term after that would be 1 plus 1, which would be 2. So if you have t of n, the term right after that is going to be t of n plus 1. You can write an equation to find this term if you know what t of n is. So if we know what this term is, we can find what this term is, and we can write an equation. That equation would look like this. We would say, well, first of all, we would have to know the term, one of the terms. So say we know the first term. In this case, we knew the first term in this problem was -8. We would have to know at least one term to write a recursive equation. And so if I wanted to write the recursive equation, I would say I am looking for this term that is after this term. What would I have to do to this to find this? Well, up above, looks like I added 6 every time to get to the next term. So if I know one term and I add 6 to it, I will have the next term. And that is my recursive equation. You have to know one term in order to find the next term after that. The problem with this equation is, if I ask you to find the 100th term, you would have to know the 99th term before you could find it. Where in this equation up here, if I wanted to find the 100th term, then all I would have to do is plug it into that equation. It would tell me the answer. All right, let's move on. Suppose you have this equation. This is an explicit equation. We can see that this is y equals mx plus b form, even though we're using t of n and n for x and y since this is a sequence. All right, first thing they're going to have us do is we want to write the first 4 terms. So if you have n and t of n, we want to write the first 4 terms. So 1, 2, 3, 4. If n is 1, I plug it into the equation and I have 1 times 3, which is 3, and 3 plus 5, which is 8. I plug in 2. 2 times 3 is 6, and 6 plus 5 is 11. I plug in 3. 3 times 3 is 9, and 9 plus 5 is 14. And I plug in my 4th term, I get 12. 12 plus 5 is 17. So my first 4 terms would be 8, 11, 14, and 17. Now, what if they asked me to find the 15th term? If I wanted to find the 15th term, I could take my equation, my explicit equation, and use it to find the answer. So I would say, well, t of 15 is equal to 3 times 15 plus 5. That would be 45 plus 5. And my 15th term would be 50. So that means if I had carried this all the way down to 15, I would have found out that 15 goes with 50. And that was pretty easy to find because I had an explicit equation. What if they asked me to find the recursive equation? So if I want to find the recursive, let's write that down. Find the recursive equation. Well, I have to know a point. Let's just go with the first term. I know that t of 1 is equal to 8. So we have to have a starting point. And then if I want to write the recursive equation, I'm going to say, well, to find the next term, I would have to have the term that I know, and then I would have to add, well, what did I add each time? Well, let's look up here. You can see in your chart that you added 3 each time. And where did I get the 3 from? Well, that was the slope in my explicit equation. So if I know the slope and I know a point, one term already, then I can find the next term. So the term I'm looking for is the term right before it plus what I have to add to get there. And what I have to add is 3. So this would be my recursive equation, knowing that I always write the point that I know, or I have to have a point, and I call it a point because it is. You can see the point right here. Okay? I have to have a starting place, and then my recursive, all that does is tell me what the next point would be, or the next term would be, if I add the slope on the end. Okay, now the last question here is, how would you find the 15th term if you only had this equation right here? Suppose we didn't have all this other information up here. We just have this. If you only had the recursive equation, what would you have to do to find the 15th term? Well, the only way I can get to the 15th term is if I know the 14th term. I'd have to find the 14th term, add 3 to it to get to the 15th term. So I would have to find all the terms up to and including the 14th term in order to find the 15th term. So this, if this is all I had, that would take me a while because I'd have to go all the way from 1, 2, 3, 4, all the way to 14. And then to use this equation, I would plug 14 in right here, the 14th term in right here. And I would add 3 to it, and I would have my 15th term. Where up here, I was able to find my 15th term by just substituting 15 into this equation. So you can kind of see the difference between an explicit equation. It tells me a lot more information really fast. A recursive equation, you have to know the term right before the one you're looking for, or you're going to have to do a lot of work to get there. Okay, next problem. Okay, now they're going to give me a recursive equation. Notice they gave me the starting point. They're saying the second term is 19. And then I have this equation. I'm looking for this term, and I have to take the term right before it and subtract 2. All right. So the first thing I want to do is I want to write an explicit equation. I want to write an explicit equation from the recursive equation that I know. Well, to do that, it might be helpful if I did a little XY chart or T of n chart, since this is a sequence. All they give me in this problem is that the second term is 19. So here's the first term, here's the second term, which is 19. And that's all I know. The only other thing they gave me is this right here. What are we doing to get to the next term? This is my slope, if you remember. So if I subtract 2 to find the third term, I'm going to get 17. And if I subtract 2 again, I'm going to get the fourth term, which is 15. So if I plug in 19 into this problem and subtract 2, I have the next term, which is 17. And then I plug in 17 and subtract 2, I get my 15. So if I want to find the first term, instead of subtracting 2 going this way, I'm going to add 2, and 19 plus 2 is 21. Now if I want to write an explicit equation, what do I have to find? I have to find m, and I have to find b. Well, I already know what m is. I can see m in my recursive equation. That's my slope. So right here, I can also see it right here and here. So my slope is -2. I'm subtracting 2 each time. The only thing I need is my b, or my starting point. So I'm going to go back one more. I'm going to go up here to 0. And if I'm subtracting 2 going this way, I'm going to add 2 going this way, I get 23 as my b. So what is my explicit equation? I'm going to say it's T of n equals the slope, which is -2, times n plus 23. And you could check that. If you plugged in 1 right here for n, 1 times -2 is -2. -2 plus 23 would be 21. So you plug in 1, you get your 21 back. So this equation would work to find more points. Now, the next part it asks, is this an arithmetic, geometric, or neither sequence? Well, since we're subtracting 2 each time, and you can also look at your equation. This equation is in the form y equals mx plus b, so it's linear. So therefore, we have an arithmetic sequence. And the reason why is because we are subtracting 2 or we are adding a -2 to get to the next term. All right. So basically what this problem told us was if they give us the recursive equation, we can come up with the explicit equation. If we want to be able to find answers faster, we can turn this into this. Next problem. Given this explicit equation, so they're going to give us an explicit equation again. This is in the form y equals mx plus b, or in this case, T of n equals mn plus b. I want to write a recursive equation. So we're just learning how to go back and forth between explicit and recursive to explicit. All right, so what do we know? Well, there's a way you can do this which may help you the first time we do this. After this, you may not have to do the little chart anymore. But let's do a chart and come up with a few points. Our first term, if I plug 1 into this equation, I have 1 times 5, which is 5, and 5 plus 8, which is 13. And then my second term would be 2 times 5, which is 10, and 10 plus 8, which is 18. And then 3, the third term would be 15 plus 8, which would be 23. So you can look and say, hey, I'm adding 5 each time. But I really already knew that because I can see what my slope is right here. Now, the 8 comes in because when I subtract 5 going backwards, 13 minus 5 is 8. So I really can see all the information that I need to write recursive. The only thing I did need to find is a point. So let's just use this one right here. We know that T of 1 is equal to 13. So we have a place to start. Then I write an equation. I am looking for the term after T of n. So with the recursive equation, I always start with T of n plus 1. It will always be equal to T of n, the term that I know. And then what do I put last every time? I'm going to put, how do I go from one term to the next? How do I go from here to here? How do I go from, if I know, am I at this term and I want to get to the next term, what do I have to do to it? I have to add 5. Or I add the slope. I put the slope added or subtracted on the end. And that is my recursive equation with my starting point. With a beginning point, I should say. And you can, it could give you 323 as your point or your 0.8. It could give you anything as long as you have somewhere to start. Okay? All right, we have one more problem. Given this sequence, the first thing I want to do is I want to find an explicit equation. So to do that, again, explicit means in the form y equals mx plus b. So I need to find m and b. Well, I look at my sequence, and it looks like I'm adding 2 here, I'm adding 2 here. I'm adding 2 here. So my slope is 2. My b, this is term 1. I want to find term 0. So I'm going to go backwards. And since I'm adding 2 going this way, I'm going to subtract 2 this way. And that means if I subtract 2, I'm going to get 5. So my b in this case is 5. And I have enough information to write an explicit equation. I say t of n equals m, which is 2, times n instead of x, plus b, which is 5. There is my explicit equation. Remember, an explicit equation is in the form y equals mx plus b, but using n and t of n instead. That is the type of equation we are used to, we really like. It tells us lots of information. Now, let's use that same sequence to find the recursive equation. Okay, to find the recursive equation, let's have 1 point. Let's use the first one. T of 1 is equal to 7. Okay, and then I'm going to write the equation. Now, what was the first thing I put for a recursive equation? I don't start with t of n like I do in explicit. I start with t of n plus 1. It is always equal to the term right before that, which is my t of n. And how do I go from one term to the next? Well, in this case, what did I do to go from one term to the next? I added 2. So I'm going to add 2 here. And that is my recursive equation. My recursive equation will always have the term I'm looking for, it equal to the term right before it, and then I'll always put my slope. I will always put my sequence generator last. And that will tell me how to go from this term to that term. And that sums up pretty much what we did today. So use these examples that we did in your homework. The first couple problems are just like these examples that I worked.